Okay, welcome to the session on amplitude, period, and reflection. This is the problem session. I'm going to do 4 problems, the first of which, problem A, is actually not in the edition that's being currently used, but I figured I'm going to use it from a previous edition because it kind of gets 2-3 things done at once. It says graph each family of functions for y equals a sine x for a equals 1, 2, or 3, and then graph also family of functions a cosine x for a equals 1, 2. So I'm going to go to a graphing calculator and do that. Okay, I'm just coming off the, I think I'm going to put in here pi over 4 again. There we go. And here y equals, I think this just comes from the recording the lecture. So here we have 1 times sine x, and then we have 2 times sine x, and then we have 3 times sine x, and when we graph them all at once, it's going to look like this, except I think my window setting is a little bit too small. I'm going to try to stop this here. Yep. Okay, because I will end up with an amplitude of 3, so I better change my y max and minimum. So again, here's the one with the amplitude of 1. There's one with the amplitude of 2. And there's the one with the amplitude of 3. And then really the same for cosine, 1 cosine x, 2 cosine x. And then I guess it doesn't want this one here, so there's the cosine with an amplitude of 1. And there's the cosine with an amplitude of 2. And that was actually it for this problem. Okay, the next one says graph for these different periods and coefficients b. Again, period is 2 pi over b, or b equals 2 pi over the period. So here it says graph y equals 2 sine 2x. By the way, these next problems are actually directly from the book. So you just have to reference my letters to the problem numbers in the book. So y equals sine 2x. That means b equals 2, and period is then going to be 2 pi divided by 2, which of course is pi. Again, I guess I'm using pi over 4 on the first. Well, I'll be using pi over 6 when I actually get there to graph that. The next one is going to be y equals sine 1/2 x, so the coefficient b is 1/2, and then the period comes out to 2 pi divided by 1/2, which is 4 pi. Okay, and then the next one is going to be y equals cosine 1/3 x, so the coefficient b is 1/3, and the period is going to be 2 pi divided by 1/3, which is 6 pi. And then there's one more down here, which is y equals cosine 3x, so b equals 3, and the period is 2 pi divided by 3. When I plug in that, b equals 3. Doing it on the calculator. So the first one is sine 2x. Now I'm going to change the Windows settings. I guess I'll make a scale of pi over 6. For all these problems, it look like I have an amplitude of 1, so I might as well change the y min, y max to -1 to 1, and then I graph, and there is the sine 2x, and because of the 2, the sine wave is faster, and we're able to squeeze more waves in the same window setting here with a window setting of 2 pi, and with a period of pi that we had calculated earlier, we of course come up with that there are 2 sine waves in here. Okay, the next one is going to be sine 1/2, so 0.5x. Because the 0.5, we're stretching the graph, and we come up with a period of 4 pi, and so of course only half of that sine curve is going to fit in here. And there it is, just the first half of it. Then we're going to do cosine 1/3 x. Because of the 1/3, again, we're stretching the graph. We're stretching factor 6 pi, so we're only going to see the first third of this cosine graph. So it just passed, I'm sorry, whoops, it was supposed to be a cosine, right? So that needs to be changed. Cosine, there we go. Try it again. So we're just a little bit past its first x-intercept that would occur at 3 pi over 2. Actually, I was supposed to change the window settings to, or the scale to pi. Oh well. Okay, do it one last time. There we go. Yeah, so we have a scale of pi. So that looks like, yeah, between pi and 2 pi, which is 3 pi over 2. Okay, one more. It says cosine equal 3x to be graphed, and the window setting is supposed to change to a scale of pi over 6 again. And then I graph that. And then we have the period is 2 pi over 3 with this one, and because of the b equals 3, we're able to squeeze in 3 of such cosine waves. And I just noticed in looking into my notes that I actually had said that I would switch the window settings to the period, which I didn't do, so let me do it on this one. So the window settings here, I switched that to 2 pi over 3. And then I graph, and we'll see that we're back to exactly 1 period within 2 pi over 3, or on the last one, because I forgot about it, 1/3 x. And if I change the window setting here to 6 pi, right there, 6 pi with a scale of pi, I get exactly 1 cosine wave again. Okay. The way I graph them on the graphing calculator looks slightly different from what I have in the script. That's because I had done this problem section before. Now I'm kind of renewing it, but apparently I'm using different window settings accidentally, but overall it's still the same problem. Okay, next problem says, give the amplitude and period for each of the following graphs. These are actually graphs you find in your book in order to get them on the screen. What I did is I used an online graphing calculator that I found at apparently graphcalc.com. By the time you're reading that, maybe that has changed, but it didn't take me long to find it, just typing in online graphing calculator, and that was one of the first ones to pop up, and then I copied and pasted in here. So here we go. Maybe I do zoom in a little bit there. So here it says that we're supposed to look at the graph and give the amplitude and the period of each of these graphs. So this graph here starts at 0, and then it hits 0 again at pi, and then 0 at 6.28, which is 2 pi, which means its period is simply pi. I've written it down there. We have an amplitude of 1, 2, 3. I might have to sneeze here, so I'll turn off the mic. Okay, I'm back. So an amplitude of 3, and because it starts at 0, that's of course a sine. So overall, this would be here written, the equation would be written, not that it asked for it, but the equation would be written as y equals 3 sine 2x, because we would have to calculate that b equals 2 by using b equals 2 pi divided by pi. Okay, the next one we're going to look at, well, it starts at 1 here on the y-axis, so that should be a cosine. It's going back to 1 at 12.56. That's 4 pi, so it has a period of 4 pi and amplitude of 1, 2, 3, 4. The equation would be y equals 4 cosine 1/2 x, because we have b equals 2 pi divided by 4 pi. And the third one is that, again, we have a sine because it starts at 0. We have an amplitude of 1, 2. And then the period is going to end up, well, we have here, there's the 0, there's the next 0. So the period is at 2 and an integer 2. And if we wrote this down, it would be y equals 2 sine pi x, because the coefficient b comes out to 2 pi divided by 2. Okay. One more problem to do. It says graph the following. I'm going to just pause for a moment so I can find it in my notes. Sorry about that, I haven't yet paused, so I'm going to try this again. Okay, I'm back. So graph y equals 2 sine 1/3 x, and then graph y equals 1/2 cosine 3x, and I'm going to do that in a moment. The k here is actually extraneous. That's actually for the next section. So the amplitude is obviously 2. The coefficient b equals 1/3. Because of that, p equals 2 pi over 1/3. Period comes out to 6 pi. On the other one, it's y equals 1/2 cosine 3x. And so the amplitude is 1/2. The coefficient b is 3. And the period comes out to 2 pi divided by that 3, so 2 pi over 3. And now we're going to graph it. So the first one was 2 sine 1/3 x, and then I'm going to change the window setting and told myself to change it to 6 pi. 6 pi with a scale of pi, which I already have, and I guess in my script I changed it to -2 and 2, which makes sense because of what the amplitude is, and because I changed the total window to 1 full period of 6 pi, that's where we're getting 6 pi, or 1 full period in here, in the window. Okay, and the other one says 1/2, so 0.5 cosine of 3x, and then I change the window settings to the new period of 2 pi over 3, so 2 pi over 3. Perhaps on the lower right here a moment ago you actually saw all these sine waves, cosine waves inside 18 point something, whatever that 6 pi was a moment ago. But now I shrunk it to just one period of 2.09, and then the scale is being changed to pi over 6. And I'll leave the y the way it is. So here we're getting again one full period because I told it to. And then, of course, the amplitude is quite squeezed. And that was the problem section for the chapter on amplitude, period, and reflection.